So, very random video here. For a while, I've had a Dell Optiplex 7090 in stock. It's something I bought at an industrial auction. And it wasn't ready for sale because the power button, this isn't the right one, but it's from the same manufacturer. You see the split plastic? They do that so that they can feed the contact lines for the LED that's inside of it in between those. So that's why the plastic is split. And then it connects behind there to depress a little concave metal disc, and that's your actual contact for the button. So on that one, this top half of the plastic had broken off. Someone pressed the power button too hard too many times and it snapped. And I have had a hell of a time trying to find the right model replacement. I don't even know if it's actually available anymore. I'll put what I found in the description of the video, as well as this model. So once I actually got it and I could see the individual item, because I was going off of data sheets and I couldn't see the actual dimensions, or I would have been able to tell, like, the one that's on the motherboard is that deep, not this deep. So it's definitely the wrong model. But I took my caliper, and the dimensions on this plastic bit are 4 millimeters square. The dimensions on that plastic bit, I'm pretty sure match. The LED is different, but I'm able to extract the LED from there. Ooh. Yeah, let's give it 2 volts. All right. So, using my Advantest precision source, I was checking to make sure that I understood, what size positive, what size negative, because I was thinking I'd modify this to solder it in. But then I realized on the Optiplex 7090, the power switch has a clip-on metal frame holding things in. It's how they did the assembly. Part of that frame is soldered in, and if I'm careful, I should be able to just bend it back. Too many back and forths and you'd snap it, but once open, once closed, I think it'll be okay. I'll need to redo the thermal paste. But yeah, my plan is to extract the plastic bit and surgically repair the actual button, since I can't find a replacement. And I think the brand is Bourns, Bourns, for the button. But again, I'll put it in the description of the video. So it's just that plastic bit that's broken. And I'm going to see if I can take it out of this without destroying it, and then put it in that and see if we have the thing restored. These, by the way, for an individual surface mount component, or no, this through hole, but still, this is fucking expensive. It's like almost $8 for one switch. So it's not like I can keep trying to buy a different one to see if I can find the right model. We'll see if it works. Bye. Okay, continuing the attempt to repair this micro form factor Dell Optiplex 7090. If it weren't so high spec, I wouldn't be bothering with this, but it does have I think it's like an 11900 or a 11700 or a 12700 CPU in it. So it has pretty good specs. It's like saleable for $500, maybe more. So ish, around that. So my attempt to disassemble the incorrect power button that I bought that I thought would work, I was able to disassemble it, and I was able to extract the plastic piece. Unfortunately, although it looked like it would work, once I started looking at everything and comparing under the microscope, the size difference here is just massive. The collar that protrudes, that portion is still roughly the 4mm square that I needed, but the recessed portion of the button, not the little dot, but everything behind that split, it's just too long. And then there's about a fractional millimeter around the edge that was also too much. So if I wanted to try to use this, I'd have to basically try to slice it down while not breaking it. That, or use a grinding pen to like gradually grind. And I figured my chance of success there was lower than proceeding with the attempt to fabricate some kind of plastic bit that I could attach to the original button, because the clicky portion of the button, that was still functional. It was just plastic got broken off. So I had successfully, as I showed in the previous portion of the video, I had successfully unclipped and bent forward without desoldering that little metal faceplate that clips the components of the switch together. And I was then able to extract the internals of the switch, which was basically the little plastic spacer that act as the push rod, essentially, and a convex or concave metal disc that was the contact of the button, a square metal collar that went around it, and the LED itself. If you ever have to do this, take pictures at every step. Something that really saved my butt was when I plugged in, like before removing the LED from the collar, I documented the orientation of what I pulled out, and I applied power to that LED to make sure what the polarity was, and I took pictures to show what side was positive and what was negative, so that I knew how to insert it, positive versus negative. And for this one, positive is left, negative is right. If you are the camera and you are facing it, your left is positive, your right is negative. So what ended up working for me, I looked around I was trying to find a straw or whatever, or some circular beads. I took a small ferrule. I have a kit of a ton of different sizes of ferrules, and this was the right diameter to fit snug inside the little switch area and rest on top of some plastic ridging. So I used my OmniFixo, I lined them up, I used a fresh razor to very gradually slice to mark off how much I had to cut off, and I cut that much off. And then I took some UV curing solder mask, and I just gotten these just in case. Like, I didn't buy these for this purpose. I saw these on Nanotech's channel, or Nanofix's channel. I thought, that's a really good idea to keep in stock. These are precision oilers. meant for watchmakers and watch repair. And you dip them in oil to take a controlled amount of oil. In this case, I used it for solder mask, and it was perfect for applying tiny precision amounts of solder mask. Basically to make spot welds, so to speak, to tack it in place and then gradually put more around the whole area, making sure everything stayed lined up because it's really tiny and finicky. And in sequence, hit it with UV, solidify it, hit it with UV, solidify it, and gradually make it so that it's nice and solid and intact and not shifting around. And the LED is inside there. You can see the contacts on either side. So I think this is going to work. I'll make part 3. This will all be integrated in one video, but I'll make the third part after I install it and see if I can get the thing to boot. Wish me luck. Oh, and I did more searching for trying to find what the correct replacement switch was. I ended up going through the entire list of every right angle illuminated switch on DigiKey and Mouser. It was about 700 total entries, literally eyeballing every single one. I think this is the correct one, or at least a compatible replacement. It is not an exact replacement. If the picture is accurate, the version I have has 2 little plastic pass-through dots on the bottom, not the top, but I think dimensionally this is correct, although it does not show the cutout. And other entries do show a cutout, so it's not exact. But it might be a compatible replacement. I don't know for sure. If this doesn't work, what I'm doing right now, then I'll probably be ordering it next. It's not terribly expensive. I mean, by the standards of an electronic part, $4.60 for a SMD component is darn expensive. But yeah, it is what it is. So hopefully I won't have to order it, and hopefully I have fixed it. But in case you run into the same thing, this is my current best guess on Mouser. For what I think is the compatible replacement. So you could see all of that. All right, bye. Okay, so I still need to reassemble it. I need to redo the thermal paste on the CPU, but I do believe this worked. I did have to take an X-Acto, or a fresh scalpel really, and shave down the solder mask that I used around it to give enough clearance around the that little metal snap-in piece. But it looks like it survived being bent at a 90 and then bent back once. And it has full freedom of movement. It goes clicky. I also had to, before I put this together, I had to shave down some corners so that that little, there was a little metal square. Here, I'll grab the other one. So there was a metal square like this, except on this one side had a layer of Kapton tape on it because it was being used to press down on the contacts for the LED. So I had to shave off some of the solder mask before assembly to get that so it pressed down all the way and it wasn't impeded in keeping that LED contacting its contact points. Otherwise it wouldn't light up. And then after I clicked it together, I did some more shaving to give it freedom of movement. But yeah, the remaining solder mask is holding strong. The button feels nice and solid. It goes click. So I think we're good. I'm going to get it reassembled and we'll see how it goes. Well, the repair's done. It is a partial success. Hold on. Hello, Fufu. Fufi says hi. So, yeah, the repair is done. The button now works, but I managed to somehow screw up the LED. Either I put too much crap in the way in terms of the thickness of solder mask, so that it's just not making contact with the contact points, or I managed, despite my documentation, to screw up polarity for the LED, and it's just not going to light up because I reversed positive and negative. I'm not really sure which, but the mechanical repair did work. The button now turns on. At first I was worried that I killed the computer somehow because I repeatedly turned it on. I felt the hard drive and the fan spun up and nothing came on. That was just me positioning it wrong because I have a really crap adapter for DisplayPort to HDMI, and it wasn't making good contact because I had to fiddle with it so it was at the perfect angle. But yeah, the repair with sticking it together with some plastic material and solder mask was effective. So cool. Bad Foofy.